Welcome back, class. Good morning to all those who are watching me in the morning. Good afternoon to all those who are watching me in the afternoon, and good evening to all those who are watching me in the evening. Now, children, it's been quite a while that we have not been able to do our environmental education class, right? So, once again, we are back because there are again two more chapters which are left. So today's chapter is the third chapter of Unit 1. Without much ado, we'll begin it. Okay, it is, today's date is of course 5th, right? Today's date is 5th. It is a very significant date. Yes, I understand. It is a big day for us. I know that if you all had been present in the school, you all would have really been able to, greet us and do, present shows for us. But then the situation is such. So today I am teaching you, alright? Today is of course Dr. Radhakrishnan's birthday, right? We commemorate his birth anniversary today and celebrate it as Teachers' Day, right? So without much of wastage of time, we are beginning with the chapter. It's a Saturday and the name of the chapter is Soil. Okay, soil, a medium of growth. I hope you will be able to see once a medium for growth of plants. This is the chapter number 3 of Unit 1. I hope you are able to see. Okay, I hope you are able to see because I know there's a lot of shining in on the board. Please excuse me, but I'll explain to you. Even if you're not able to see, I'll explain the matter to you. Alright, children. So, this is the chapter we begin with. Now, you must understand, children, that soil is the topmost fertile part of the earth's crust. Okay, it consists of both organic and inorganic material in it, which helps the plants to grow. Alright. Now, before I also draw the soil profile for you, I'll just explain to you, like, it consists of humus, minerals in it. What is humus? Humus is the organic material which is formed by decaying, okay, by decaying or decomposition of dead organisms, okay, dead matter, right? That is called humus. So now please note that I am going to draw the soil profile. Okay, it is very, very important. You must practice the diagram. Okay, I wanted you to go ahead with the project also. Let's see. I'll give you over the weekend, okay, the work. Maybe next weekend you can submit the pictures of your diagrams. And children, I am correcting now and often whenever I am getting your work, which you are emailing me in your class email ID. Now we are going to do the soil profile. Okay, as I draw, I will explain, because in case you are unable to see, I will explain it. Right? I have tried my level best to adjust the light, but let's see how far it works. Now this is the soil profile. Okay, just the thin layer on the earth's crust, okay, is called the O horizon. Okay, O horizon. It is actually the part where germination, where you grow plants, okay, and it consists of humus. As I said, humus is the most fertile organic matter, right? Now I'll just move away from the board and you can see. Just let me finish the diagram. Alright, then comes the A horizon. Okay, then comes the A horizon, which is the topsoil. Okay, which is the topsoil. Then comes the E horizon. E horizon is the alluvial layer. Okay, is the alluvial layer. Okay, alluvial layer. Now then comes the subsoil, the B horizon. I'll move off, children. Please excuse me. I'll move off once I draw, and then I'll explain. Okay. Then comes the C horizon, and then the last is the bedrock. Okay, C horizon, and then comes the R horizon, which is the bedrock. Okay, this is called the soil profile. Okay, this is called the soil profile. First is the O horizon, okay, which is the topsoil on which actually plants grow, which consists of humus. Then comes the A horizon. Okay, this much is A horizon. That is the topsoil. Okay, the O horizon consists of the humus. Again, I am repeating, this is where plants and trees grow. Alright, then comes the E horizon, the alluvial layer. Okay, then comes the subsoil. Okay, that is the B horizon. After that comes the C horizon. Okay, and right after that comes the R horizon, which is the bedrock. Okay, which is the bedrock. Fine. Now, basically the soil can be characterized into three types. Okay, the topsoil, the subsoil, and the bedrock. Now, what is the topsoil? Topsoil contains humus and minute particles along with tiny organisms. Okay, along with tiny organisms. Now, subsoil, it contains minerals, rock particles, cracks, and holding moisture. Okay, cracks which hold moisture in the soil. Excuse me, that is called the subsoil. Now, what is the bedrock? Bedrock is the unweathered rock or parent rock upon which the soil is formed. So, it is the base of the soil. Alright, it is the base of the soil. It is the base of the soil. Okay, that is called the base of the soil. So, what are the three layers basically? The topsoil, the subsoil, and the bedrock. Okay, fine. Now, soil is a medium of growth for plants, isn't it? It's a medium for growth of plants, right? Soil is the medium on which plants grow. Okay, how? Soil provides us food, shelter, clothing, and several other things, and it supports life, isn't it? It supports the many organisms like man, animals, and plants, right? Okay. Now, soil also contains a varying amount of moisture and air in between, okay, which gets trapped in between. Okay, and it contains major nutrients like nitrogen, potassium, okay, phosphorus, magnesium, calcium, and sulfur. Okay, these are the nutrients which are present there. Okay, these are the major nutrients which are present there: nitrogen, potassium, phosphorus, calcium, sulfur, etc. All right. Now, different soil have different capacity of providing nutrients. Of course, it will depend upon the variety of the soil of providing different nutrients or capacity of providing different nutrients for the growth of plants. Now, humus, air, water, and mineral components are required for growing in the soil, okay, for growth of plants. Now, another thing we must know, microorganisms are also present in the soil. Okay, microorganisms are an important segment of the soil. Now, fertility of soil varies from soil to soil, okay, and you can of course increase the fertility as well, children, by adding chemical fertilizers at a restricted level, okay, controlled way, not adding too much, then it becomes poisonous. Don't we get to hear that vegetables these days you know, they have a lot of chemical fertilizers in them because the farmers add, because to kill pesticides, a lot of pesticides in it, and that again adds on to the poisonous texture in vegetables at times. Okay, at times vegetables become poisonous due to that. So everything has to be in a controlled use, in a controlled manner. Okay, everything has to be in a controlled manner, right? Now there are also presence of acids in the soil, okay, which are good for particular crops like beans, okay, beet, cloves and tomatoes. Okay, beet, beans, cloves and tomatoes. All right. Now next, what are the types of soil? What are the types of soils? Okay, soil can be classified according to its color, texture and fertility. Okay, soil can be classified according to its color, according to its texture, how it feels, and of course the fertility. So the first one is sandy. Sandy, as the name suggests, it consists of 80% sand particles in it. And what happens? There's a lot of air present in it and it cannot retain water. Okay, there is no humus in the soil. Okay, so humus is an essential segment for the growth of plants, isn't it? And what happens? You will find it in a desert climate, isn't it? So the hot weather makes it very, very dry. Now next comes the loamy soil. Loamy soil is said to be a fertile soil because it is very rich in fertility, and it is a mixture of clay and sand. You know, it is a mixture of clay and sand, and what happens? It holds a good amount of humus and water in it. Okay, very good amount of humus and water in it. So what is it doing? It encourages, okay, it helps in the growth of plants and crops. It helps in the growth of plants and crops, right? Now the third classification what we get to see is the loamy soil. Now loamy soil is also rich, we have already explained it, details about the loamy soil. Now the next is the clay soil. The first one was sandy, the second one was loamy. Now comes the third classification of soil, clay soil. Clay soil, what happens? It has a very, very high capacity of retaining water in it. Okay, that means it holds water in it. And what happens? It has a good amount of clay particles in it and less amount of sandy particles in it. And it remains sticky and heavy. Okay, it remains sticky and heavy. So, and throughout the year, I mean major part of the year, it remains sticky and heavy. Okay, so it holds a lot of moisture in it. And what happens? Plants grow in this type of soil very easily. You can grow, you can sow a seed and you'll see it germinating very fast. Alright. So what we can zero in, okay, what we can zero in is soil can be classified on the basis of their origin. That means how they are formed. Okay. Loamy soil, which is carried, number one, okay, loamy soil is carried by the wind. And what does it have? It has sand and loamy particles in it. Okay, now alluvial soil, yes, that is also supposed to be very, very fertile for growth of crops. That is carried by the river. Okay, that is carried from the upper coast to the lower coast. Okay, upper coast to the lower coast. And sedimentary soil. What is sedimentary soil? Sediment means the deposit at the bottom. So where does it originate? It originates from the underlying rocks. It originates from the bottom of the rocks. Okay, right. Now India is a vast country, so there are various variety of soil which helps, okay, in the growth of many types of crops. Okay, many types of crops. Like I said, alluvial soil. Okay, alluvial soil. Like I said, alluvial soil. Alluvial soil, what happens is found in the foothills of the Himalayas and the peninsular plateau. Okay, and it is a mixture of clay and sand, and it is, as we have already discussed in the previous point, that it is carried by the river from the upper coast to the lower coast. All right, and it is also known as the Dumat soil, D-U-M-A-T. Okay, the Dumat soil, right? And what are its characteristics? It is rich in mineral contents like phosphoric acid, okay, lime and potash, right? And it is rich in organic content. So first is mineral content, then is organic content, and it is very suitable for agriculture, but it lacks nitrogen. Okay, it does not have nitrogen. It is deficient in nitrogen. All right. So these are the major characteristics of alluvial soil. Now children, as I also wanted to state that it is going to be a 30-mark paper for you. It is going to be based in the form of MCQs and one-word answers. So nothing will be out of the syllabus. You must read the textbook at least 3 times. That means you must read the chapter. Whatever question and answers I have given you, that covers the entire chapter. But you have to read the chapter to know what is the chapter about, so that there are chances of me picking up 2 to 3 questions from the chapter. Okay, don't worry, we are going to do, I'll be uploading many revisions related to the same before your examination begins, right? I hope everybody has downloaded the syllabus as well as the date sheet, right? So you will get to know, don't worry, because I'll just do many revisions on the 4 chapters. Now, alluvial soil, as I said, is found in the deltas of the river, because the rivers carry from the upper coast to on the deltas of the river Krishna, Kaveri, Godavari and Mahanadi. Okay, these are the major rivers which carry alluvial soil. Now next comes the black soil. Black, the name suggests, is very, very fertile. And how has it been formed? It has been formed by, solidified lava. You know what is lava? That which, the molten material which flows out of volcanoes. Okay, it is formed from that. Okay, and it is mostly in the regions of the Deccan Plateau. And where is it found? Mostly Gujarat, Maharashtra, Madhya Pradesh, and certain parts of Tamil Nadu, Andhra Pradesh and Karnataka. And what are its characteristics? Okay, black soil, the name as it suggests, it is formed from molten lava. Okay, lava, it is formed from solidified lava. Okay, lava, the molten matter which comes out, okay, which oozes out when there's a volcanic eruption. All right. So what are its characteristics? Its characteristics are, because it is rich in iron, it is black. It has the capacity of, holding moisture for a long time. It has the capacity of retaining moisture for a long time. But what happens during the rainy season? It becomes very difficult to plow through the fields consisting of black soil. It is rich in calcium carbonate, magnesium carbonate, potash and lime. These minerals are already present. Okay, potash, lime, calcium and magnesium carbonate. Right. But it lacks, see, all the soil you'll see, either there's an increase in something or there's a deficiency in something. It will not have everything in it, okay. It lacks phosphoric acid, okay. It lacks phosphoric acid and organic content. And it facilitates the growth of cotton and sugarcane, is it? Okay. And as you know, the other name for alluvial soil is Dumat. The other name for black soil is cotton soil. Now let's move on to the red soil. Red soil is caused because of the igneous rocks which is spread over which states? Jharkhand, Bihar, Orissa, Madhya Pradesh and Tamil Nadu. Okay, this is formed from igneous rock which spreads over this area. And what happens during the dry and hot season? lot of iron oxide appears and thus changes the color. It looks more red because you know iron gives that reddish tint. Okay, so during the dry and hot season there is a formation of iron oxide and which makes the soil look redder. Okay, so that is why it is called red soil. Alright, and what are its characteristics? It is rich in iron content, yes we know, right? But it is full of pebbles and gravels and it lacks humus, the essential part. So you will hardly find much of crops. In fact, it is not at all fertile for growing crops. And it is porous, there are holes. So it is less fertile. And what does it lack? It lacks lime, potash, which is very essential for the growth of plant. And of course, humus. Imagine humus is not there. So it is not at all good for growing crops. Now, next, so we know what are alluvial soil, we know what is a black soil, we know what is a red soil. Now we are going to talk about laterite soil. Now, laterite soil is found in regions with heavy rainfall, okay? Rainfall which exists, which persists for a long time, in those areas we get laterite soil, okay? Now, what are the areas? Western Ghats, Chota Nagpur Plateau, Andhra Pradesh and Tamil Nadu are the regions. And these regions again are further divided into two, upper and lower, okay? Upper region, it is full of gravels, gravels means when you get to see, the trucks carrying sand, you'll see a lot of pebbles and tiny stones and medium-sized stones. So that is called gravel, which is also required for construction purpose, okay? And so what happens? It is not fertile, okay, and it is porous. So it facilitates only the growth of Chinchona and tea. Only the growth of Chinchona and tea. Only the growth of Chinchona and tea. But the lower region is fertile, okay, and it is very good for the cultivation and the growth of rice, okay. So why? Because it contains a lot of minerals in it, like iron, okay, it contains iron in it, it contains aluminium in it, it contains magnesium in it, and all those minerals which are needed, okay, which are required, which promotes growth are present here, okay. But overall, laterite soil is not that fertile. Overall, if you consider both the region, upper region as well as lower region, laterite soil is not that fertile. Next is the mountain soil. Next is the mountain soil, okay. We have discussed alluvial soil, we have discussed black soil, we have discussed red soil. Now, laterite soil also we have discussed. Now, mountain soil, as the name suggests, it is found on the hill slopes of Himachal Pradesh, West Bengal, of course, and Assam. And the name itself is, it is also known as the tea soil, okay. It is good for cultivation of tea. It is rich in iron, but it lacks lime in it, okay. So, this is known as the tea soil and it promotes the growth of tea. It is found in the foothills of the Himalayas of West Bengal and Assam, alright. It lacks lime in it, but it is overall fertile for the growth of tea. Now, the sixth type of soil, okay, is desert soil. And how does it, originate or come into existence? It comes due to excessive weathering, okay. Excessive weather condition means extremely dry and hot, okay. So, it lacks moisture. So, what happens? There is a shifting, like large sand dunes from one place to another by strong winds, alright. So, Thar desert of Rajasthan is an example where desert soil persists, okay. Now, soil as a home for organisms. The next topic is soil as a home for organisms. Now, I am going topic by topic. Why am I explaining? It will become easy when you are reading the chapter, because this is also covered in geography. If I am not wrong, this has been covered in geography as well, alright, this particular soil chapter, okay. It is a part of geography as well, right. Now, how is soil a home for organisms? Okay, there are a presence of thousands of microorganisms in the soil. Okay, many organisms grow in large number, especially bacteria. Okay, fungi, algae, protozoa, all these are again in biology you will get it, isn't it? In biology you will get it. So the activities in the soil of these organisms are listed. Okay, what do they do? You know, soil organisms, fungi, what do? They hold on together with the roots of the higher plants. And what do? They are helpful for obtaining water and nutrients from the soil. They get stuck onto the roots of the plants. Okay, and some of the soil organisms, they secrete mucus. Okay, they let out, they give out, okay, they ooze out mucus for, you know, cementing. What does cement do? They join, isn't it? So they secrete or give out or ooze out mucus, which helps as a cementing factor for holding together soil particles. Okay, what happens now? Burrowing animals like rabbits and all, they're going on digging. So what happens? There's a shifting of the layers. Okay, so what do? They increase in the aeration of soil, because they are always shifting the layers when they're digging. The topsoil, you know, gets interchanged. Okay, there's a shifting of layers. Right. Now, the bacteria which are present in the soil, some of them also, these are the various activities which help to retain and maintain the fertility of soil. Okay, that is what I am discussing. How? Okay, they fix the nitrogen from the atmosphere in the soil. Right. The major function of soil microorganism is to decompose. You know what is decomposing? Like decaying dead organism. Okay, that is the major function of microorganism. Okay, that is the main function. And as a result, they release a lot of nutrient in the soil. They help in, what do? Decomposition. Okay, they help to decompose the dead organic matter. Now, soil as a facilitator for percolation and retention of water. What does it mean? It has the capacity of holding water, okay, and retaining it according to its texture. Okay, water is held in between the particles of the soil, and some of the water seeps through. Okay, it gets sucked in, it passes through due to the force of the gravity. Okay, we cannot feel it, but the earth, as we say, is continuously moving. Right. And what does it do? It goes and gets stuck up in the non-porous, the layer which has no holes in it. Okay, and as we had already discussed, the water table, and that is which forms the water table. All right, that is which forms the water table. In this way, what does it do? It helps in percolation of water and also facilitates the availability of water for use. All right. Now, water which is held in the water due to the capillary action is known as capillary water. Okay. Now, maximum amount of water so retained per unit dry weight of soil, okay, due to the stoppage of gravitational flow, is called the field capacity of the soil. Okay, is known as the field capacity of the soil, and it is either way is also known as the water holding capacity of the soil. So what happens? Water holding capacity, of course, varies according to the type of the soil. For example, sandy soil, it has the minimum water retention capacity, isn't it? As we knew that it is unable to retain water, and as a result, the growth of plants, the growth of plants and crops depend because of that. All right, it depends on that. Now, coming to the end of the chapter, what I would suggest is, again, please go through the chapter properly. Okay, please revise the chapter, read the chapter 3 times. Okay, go through the points to remember, the glossary which is given, that means the meanings, also the new words which are there. Go through properly, okay children, because your questions are going to be multiple choice question, and they will be from the chapter as well as the question answers we have done. You will have to either tick or write one word, okay, and it's a minor paper. I'm sure everybody will do it. All right, and we have one more chapter left, so soon I will also upload the audiovisual tutorial for that chapter as well. All right, so far as of now we have completed soil as a medium for growth of plants, chapter number 3 of unit 1. All right, so signing off for today. Bye bye, take care and stay safe.